I go to the board. I have a board here. Okay. Do you see the board? Do you see the board?
Yes.
Okay. We continue doing polynomial equations. How do you know? What is the clue? Give me information. Okay, you know it's polynomial equation. What is the clue? What is polynomial equation? What is the reason? It's
The power of 3?
Power 3, power 3. Power 3, okay. Power 3. Entonces, degree is 3, ¿no? The degree is 3.
Yes, the degree is 3.
Eso, bueno. How many solutions we expect when you finish?
3.
3 solutions. Okay? And this is because it's polynomial. Entonces, pero nobody answered my question. What do you recognize? What is the reason that you recognize que es polynomial? Suppose a equation like that. Suppose another equation. Que es x to the 3 over 2 plus x to the 1/2. You see this equation after that. It's a polynomial. It's a polynomial.
Oh, no.
Hey, what's going on? Maria Lucia Pastor. Yes. Hey. Putting off the microphone. Putting off the microphone. Putting off the microphone. I don't know what happened this class. It's always the same. Okay, another class, I have no problem. Putting off the microphone. And you activate the microphone when you have a question, or you using the chat. Maria Lucia say more than 1 degree. No. Okay. Es polynomial. The reason exactly. The reason it's polynomial is because the exponents are a whole numbers. Si it's a fraction number or it's a negative number, of course, it's no polynomial equation. This is no polynomial. This is polynomial because it's 3, 2, 1, 0, polynomial, whole numbers. So you expect degree 3, you expect 3 solutions. Otherwise, no. Otherwise, it's completely crazy. So this idea que degree 3 solution is only valid when it's polynomial. Otherwise, no. Okay, entonces, okay, I can see, wow, 1, 2, 3, 4. Again, factorization by grouping, no? So you manipulate the left-hand side of the equation because the right-hand side is 0 in this case. Using factorization by grouping. And you can see that the greatest common factor of this couple is x squared. Open parenthesis, inside the parenthesis, you put the remaining part is x and 1. And the second couple, the common factor is obviously 4. In this case, positive 4, open parenthesis, x minus 1. This is classical factorization by group. Now, I can see the factor x minus 1. Again, it's common factor. One more time, I factor out. Open new parenthesis. Inside we have x squared, okay, this guy is this guy, plus 4, okay, this guy is this guy. Equal this. Did I finish the factorization? Yes, I finished. Why I finished? Because this is the sum of a square. Sum of a square is impossible factorization. Sum of a square is a prime expression. We cannot factorization anymore. See, it's different of a square? Yes, we did the last class. See, it's x squared minus 4, yes. The factorization was x to 2 plus or minus. But this is x squared plus 4. Nothing. We can't do that. Because it's prime expression. And leave it like that. Okay? Now, as always, in order to find the solution, almost we finish. You separate, you apply the zero factor property that allows us to separate this factor and this factor equal to 0. X minus 1 is equal to 0. Therefore, x positive 1. And x squared plus 4 is equal to 0. Therefore, this is quadratic equation, but the best way for solving this quadratic equation is using the square root method because b is missing. Entonces I solve for x squared. I move 4 to the right-hand side like a minus 4. Apply square root both sides. This is just x, and this is square root negative 4 is, you don't remember? What is the square root of negative 4?
2.
2? It's 2, no? It's not 2. It's what?
2i.
2i. It's imaginary. Remember, when you have a negative quantity inside the square root, it's imaginary sign. And don't forget, please, double sign. Because when you apply a square root or any root, the index, even 4 root, 6 root, square root is 2, you apply double sign, double solution. Entonces, how many solutions we have in total? How many? How many solutions we can find? We found
2.
no. How many solutions we have according to the degree of the polynomial equation? 3. Degree 3 solutions. And you have 3. What is the 3? 3. What is the 3? One of the 3 is 1 positive. So 1 is real solution, real. Comma. I don't know what happened with the comma. Comma. And you have 2 imaginary, plus and minus 2. If you want, you write like that, or you write like that. 1, 2i positive, comma negative 2i. Doesn't matter. This is the same. 1, 2, and 3 solutions. 1 real, and 2 imaginary solutions. This is a solution for this polynomial equation. Any question? Any question? Any question? Any question? Come on. Super clear? Let's move on to the next example. No?
Can you scroll down for a second, Professor?
Like that?
Yes, thank you.
Okay. Let me know when you finish the copy. Guys, you can take a screenshot. You know how? And remember this video you took this video I am recording now. I posting in Blackboard of the Miami-Dade College, correct? And you watching anytime you need. Okay.
Sir, I have
please.
Anytime that the second parenthetical has an x squared in it, it doesn't always mean that the sum of the square is always prime, so you can't factor it.
Let me explain in detail that part, mister. Let me explain. Look. The binomial factorization, we have the classical a squared minus b squared. This is a plus b, a minus b. You are aware for this situation, right? However, if you have a squared plus b squared, impossible to do anything because this expression is prime. Now I need cubic also. Sum of cube and difference of cube. Both expressions are factorable expression. The formula is a plus b. That is 1 binomial and 1 trinomial, que es a squared minus ab plus b squared. And a minus b, parenthesis, a squared plus ab plus b squared. So this is binomial, two guy. This is the collection of the most important binomial expression. And the factorization, we can use in that formula. But when this is sum, it's impossible factorization because it's prime expression. Okay? Please copy that. Putting off the microphone. One microphone is saying on. I'm making noise. Okay, we're using now that formula and that formula when it's a cubic. Okay? Okay. Let's go to example number 4. Polynomial equation. Do you copy?
No, just give me 1 second. I'm sorry.
Let me know. You por the chat you say professor or activate the microphone and say professor. We can go and continue. Done? Done?
Done, yes.
Okay, good. Okay, example 4. Let me see. Is x cubic minus a equal to 0. Wow. ¿Es a polinomio? Yes or no? Polinomio, yes or no? ¿Es a polinomio? Yes, of course, it's a polynomial. Yeah. And the second question is, what is the degree of this? What is the degree? 3 is the degree. So when you finish this problem, we expect 3 solutions. 3 solutions, of course, count, repetition, or complex. So real, repeated, because I repeated and non-repeated, and when it's repeated, you count like a 2 or 3, depending on the multiplicity, no? And complex. Okay. So you can see, wow, in order to factorization this binomial, I can consider in my mind like a cubed minus b cubed, right? In the formula. This is a typical difference of cubed. Let me copy one more time the formula. The formula is a cubed minus b cubed. We have binomial, que is a minus b, and we have trinomial, que is a squared plus ab plus b squared. This is the formula for factorization, the differences of cubic. In our specific case, it's not B, A and B. A is like an X, and B is like a 2, no? Because 2 cubic is, que 2 cubic is 6, no? Entonces, the factorization, you open 2 parentheses, like that, one short, one long. Inside, we have X minus 2. Do you understand where I come from, 2? Because B is 2. Because B cubic is 8. I square the first, que es x squared plus multiplication both, que es 2x. These and these together, plus 4. Where I come from this 4? It was 2 squared. B, okay, in our example, A is x, and B is 2. So it's x minus 2, like that. And the trinomial is x squared, because A is x, plus multiplication both 2 and x. I put the coefficients in the front, 2x. Plus 2 squared, and 2 squared, I know, b squared is 2 squared, 2 squared 4. Everyone follow me? Everyone follow me? Everyone follow me?
Yes.
Okay, now, important moment. Important moment. Always, I guarantee you this idea. Look, this trinomial, when you are doing the factorization for the difference of cube or difference of sum of cube, this trinomial always is, I know, it's prime. Always is prime. Okay, therefore, you separate like that the equation. X minus 2 equal to 0. So you apply the zero factor property one more time. It's obvious the one solution is positive 2, real, nice. And x squared plus 2x plus 4, I suppose that we cannot factorization because it's prime and trinomial. And the solution, when it's prime, the reason is it's prime because in the real field, we cannot factorization. Because the reason is that the solution is complex. And how do you know the complex solution? Well, using the quadratic formula. Quadratic formula is minus b plus or minus the square root b squared minus 4ac divided by 2a. In our specific example, a is 1, b is 2, positive, and c is 4. Plugging in, minus 2 plus or minus square root 2 squared, because b is 2, minus 4 multiplication by 1 multiplication by 4, everything divided by 2 times 1. As always, we can do that, the expression inside the radical. Right? We focus it in this expression. So 2 squared 4 minus 4 times 4 is 16. And 4 minus 16 is negative 12, no? And the square root negative 12, again, one more time, is imaginary, right? Because negative quantity inside the radical. Let me see. 12, see, I break it down, prime factorization is 3 and 4, no? And the square root 4 is 2. So actually, it's 2, because the square root 4 is 2, and stay 3 inside the radical, And of course, don't forget the I because it's negative. The solution is minus 2 plus or minus 2I radical 3 divided by 2. That's it, no? You keep going a little bit because it's a complex number, no? And the complex number always we express it in a standard form. And in standard form, you copy the real part separately to the imaginary part. So you split this common denominator to say negative 2 divided by 2. So this and this together, plus or minus this and this together. Okay, 2I radical 3 over 2. It's obvious okay, this is cancelled, chan, and the answer is negative 1 plus or minus, and this is also cancelled, it's plus or minus I radical 3. Okay, let me write in elegant way the solution set. The solution set because it's important to write the solution set because I want that the professor, when I grade the test, see I know very well what the solution, what are the solutions for this equation, no? And then let me try to write solution set in elegant way like that. Okay. Solution set. Solution set for this equation is, well, we discovered here one real solution, get two. And you separate by comma. And we have two complex. And the complex is this. Contain real part is negative 1 and imaginary part is plus or minus I radical 3. So actually, this is two complex numbers. By the way, they are conjugate. So you can write like that in shortcut. Negative 1 plus or minus I radical 3. Or another student prefer separate like negative 1 plus I radical 3, comma, negative 1 minus I radical 3. It's the same. That we can write separately or condensing in only one using this sign que represent double sign, plus or minus. Any question? We are doing polynomial equation. Go ahead.
How did you get x minus 2 in the beginning of the equation?
How do you get this x minus 2 here?
Right.
Look. Unfortunately, I erased that part, but okay, I want to repeat for you. Look, I start, okay, this is my original expression. I realize that this look like similar to the difference of cubic. Then I know that the factorization is something like that. So in our specific example, this is the general formula. We have x minus 2. Do you understand where I come from this or no? Okay. This A come from by the cubic root of A cubic. A cubic is this. You take out cubic root here and you get A. B was the result of the cubic root of B cubic is the second is B. Likewise here, cubic root of the x cubic is x. And this x is this. And cubic root of A is 2. And this 2 is this. It's okay so far? It's okay? Guys, this is Miss?
Yes.
You follow
Yes.
me. Okay, good. Okay, now the trinomial part is easy. The trinomial part is, look, is A, pero A is X in our example, square, plus AB is a multiplication, this and this, but in this case, X and 2 together. I don't care the sign, que es negative. you multiplication, the actual value without sign, plus b squared que es 2 squared. And 2 squared, I know que 4, you are replaced by 4. Do you understand? And the rest you see. I separate this equation. I separate this equation in two equations. It's a linear equation. Give me one solution. And this is quadratic equation and give me two solutions. The solution here is real. And the solution here is complex. Do you see that part? No?
Yes.
Yeah. The solution for this equation was this and this. And the solution for this equation was
It's 2.
Uh-huh.
So you're just checking it right now. That's what you're doing.
No. You don't need to check it. Okay. Listen to me. In algebra, if you want to make sure everything is okay, you can check it. But it's no mandatory to checking. Only, listen, it's only mandatory to checking in the radical equation. Because the radical equation, sometimes we have extraneous solution. It's a solution that doesn't work. So in the radical equation, it's mandatory the checking. But in the polynomial, no. The polynomial, if you want to check it, you can. Or you can. But not necessary. No mandatory. If you don't check, I don't care. It's okay?
Yes.
Okay. So, any other question about number 4? I have another example, number 5.
I'm sorry.
Professor, I do have a question.
Okay, you are doing your copy right now?
Yes.
Okay, go ahead.
It's about the other formula that it was minus b plus and minus, and then it was square b. It was the other one that you used.
It's a quadratic formula. So this formula you say, let me see. Minus b plus and minus square root b squared minus 4ac divided by 2a. You say this formula, miss?
Yes, that one.
This is a quadratic formula. This is a quadratic formula que solve the quadratic equation. So any quadratic equation, you can solve it in easy way using that formula. We practiced it last time. You remember? You are not here. You were not here.
I don't think I was there.
Okay. Okay, let's go directly to number 5. No, I can erase the board or no? Erase the board or no? No.
Professor, I have a question.
Please go ahead.
I'm sorry. I don't mean to hold up the class. How did you get the second part of that equation, x squared plus 2x plus 4? Where does that come from? How did you derive that from x cubed?
You are talking about that part?
No, yeah. How did you get that?
Easy. This was the result of the factorization. When you factor out this expression, binomial, 1, 2 guy, using this formula, I put here to see it's analogous. And this is the general formula I explained before. To factorization, a difference of cubic. Difference of cubic. In our specific example, we have also difference of cubic. But the variable que participate in the game is x and 8, not a and b. So this is the same, but replace a for x. Look, a for x and b for 2. Do you see that?
Yes.
Eso. Perfect. Okay, I know this is the student forgot. I don't know why the student forgot that this algebra, but this is intermediate algebra. I teach in the morning. This is factorization, but just copy the formula and apply in a specific example. Okay, let's go to number 5. Number 5 is the last polynomial equation, and you help me to solve it. Number 5. Number 5 is way. Yeah, there you go. X to the 4th power minus 16 equal to 0. ¿Es polinomio, yes or no? Poly, yes or no?
Yes.
Yes. What is the degree?
4.
4 degree. How many solutions we expect when you finish that?
4.
4 solutions. Good. What formula you propose me using? It's a binomial. Look at that. 1, 2. Binomial expression. Binomial expression. I know the formulas for the binomial expression. Okay. It's different of a square, is different of cubic or sum of cubic. It's not cubic because the exponent is 4 and 4 is even number. Therefore, it's obviously different of cubic. So we one more time using this formula. And this formula is valid not only when it's 2. Si es 4, it's also valid, but of course it's square root. So you separate in 2 parentheses. Square root this guy is x squared. And square root this guy is 4. And you separate by plus and minus. Something like that. Correct? I use it one more time, this formula. But I finish? No. Why no? Because I need to continue the factorization. This expression is prime. Because it's sum. Sum of squares is prime. But this is not. This is different of a square. And one more time, I factorization using the same formula in 2 pieces. Square root of this guy is x. Square root of 2 plus or minus. Everyone understand the factorization? Yeah, I finish. I don't touch anymore. I cannot continue because this expression is prime is impossible. This is impossible. Break it down. When it's minus, yes. When it's plus, no. Okay, now I separate my problem in 3 equations. One first equation, the quadratic equation, it's something like that. X squared plus 4 equal to 0. It's a quadratic. Look at the exponent 2. I suppose we have 2 solutions, no? In this equation, and x plus 2 equal to 0. One solution because it's degree 1. And x minus 2 equal to 0 is degree 1 also, one solution. And the solution for this is easy, is using the square root. So you move forward to the other side. Let me write the solution here. Apply square root both sides. X is equal plus and minus 2i. Remember, one more time, imagine a negative quantity, a negative number. Inside the square root, we expect solution imaginary. And here, no. Solution is negative 2. I move 2 to the right-hand side like a minus 2. I move to the right-hand side like a positive 2. And we finish. Now the rest is right solution set. The solution set for this equation is solution set is you open this curly bracket and you listing separate by a comma the solution. The solution is one of you have 2 real solutions, 2 negative 2. It doesn't matter the order. You another 2 put negative 2 here and positive 2 here. It's okay. Comma and 2 imaginary get plus or minus 12. Ow. Plus or minus 12. In total, 1, 2, 3, 4 solutions. We can write like that or like that. Minus 2, 2, 2i, negative y. 4 solutions. Because the polynomial equation, degree 4. And we expect 1, 2, 3, 4 solutions. Any question? Any question? Easy. Okay, so basically, the only thing you have to remember is the technique of factorization. So you have equation, degree 4, degree 3, degree whatever, and the left-hand side. And you are doing a different of factorization. What is the technique for the factorization? Well, trinomial. And what is binomial? We have different case, different of a square, different of cube, sum of cube. And of course, when you have 4 term, factorization by grouping. That's it. End the story. We have to practice. Yes, we have to practice. In the review package for the test number 1, we have 1, 2, 3, 4, 5, 6 examples more of the polynomial equation. Any question? Do you understand a little bit? Okay, no. Ovino Romero, no. No what? What say no? Yes, Ovino say yes now. Okay. Now we continue with the equation, but another kind of equation, more complicated, but important, extremely important. This equation is called, it's another name, is equation que es called quadratic. Quadratic in form. Entonces, this equation actually is not quadratic. It's not quadratic equation. But we can do something in order to transform it to quadratic equation. Entonces, what is the most important characteristic of this equation? Let me put the first example. It's elementary, but I want to complicate more this. Suppose this 3x to the 4th power minus 2x to the 2nd power minus 1 equal to 0. I have a question. This is a polynomial equation, yes or no? What do you think?
Yes.
Yes, of course it's a polynomial equation. What is the degree of this polynomial equation?
4.
4 degrees. So when you finish, we obtain 4 solutions. However, this equation is more. You can identification like a quadratic in form. What is the clue to identification que es quadratic in form? The reason is that we have 2 exponents. The first exponent is 4, the second is 2. And the relationship between the exponent is twice. That this exponent, the greater exponent is twice this. Therefore, this is the characteristic que recognize or identify que es quadratic in form. So we are doing one shortcut que help me to convert this equation, que es polynomial equation degree 4, en one equation que es degree 2. O sea, quadratic equation. So this is traditional in algebra or in mathematics in general, chain of variable. Chain of variable. And I don't know why the traditional variable to change a variable is u. Don't ask me why. U is the classical letter we use it to change the variable. So I propose you change the variable x, get the original variable, like a new variable is u. But you take always x squared. How do you know that? Because you take the smaller exponent. So we have 2 exponents. The smaller multiplied by 2 is the greater exponent. This is the classical interpretation que es quadratic in form. But when you are doing the chain of variable, you take like a u, the smaller exponent. So you rewrite the equation now using the new variable que es u. Es obvio que x squared is u by definition, no? I create this idea. Es minus 2u. But this, que es double, es obvio que es u squared. Do you see the transformation or no? The thing that we are doing is change the variable. It's super easy. It's super easy. Well, in this case, it's easy. And all that I want to present today is a little bit more interesting and complicated. But I create the first elementary example que es obvio que everyone saw, no? I suppose que saw. Okay. Entonces, what is the key idea? The key idea is transform a polynomial equation. Degree 4? No. Now it's quadratic equation. This equation now is quadratic equation. Yes or no? This is quadratic equation. Yes or no?
Yes.
It's a classical quadratic equation. And we solve it using the classical quadratic formula. A is 3, B is negative 2, and C is negative 1. Minus B plus and minus square root B squared minus 4AC divided by 2A, quadratic formula that we're using always for solving quadratic equation. Not always, but frequently. Entonces es minus, the formula contains minus, pero B es negative, double negative become positive. minus 2 squared minus 4 multiplication by 3 multiplication by 6 and negative 1 divided by 2 times 3 is 6. 2 times 3. So we focus it in the expression inside the radical. Okay, according to the order of operation is the first part. This is 4 positive, negative 2. Regarding the negative positive is positive. And this is plus because we have double sign here, negative and negative together is positive. So it's 12, no? 12. And 12 and 4 is 16, and square root 16 is 4. And we have 2 plus and minus 4 divided by 6, sorry. 2 times 3 is 6. Everyone follow me so far? Good. Okay. Okay. Now, as always, I separate 2 plus 4 divided by 6 and 2 minus 4 divided by 6. So I separate double sign plus and minus like a positive and negative separately, and 2 plus 4 is 6, and 6 divided by 6 is 1. Wow, this is my first solution. And this is 2 minus 4 is negative 2. Divided by 6 is negative 1/3. Okay. That was easy, but this is not the final answer. Why no? Because remember, we are doing a chain of variables. The chain of variables was fantastic because it helped me to convert one equation que es polynomial equation degree 4 and one quadratic equation super easy que I computed using quadratic formula. But this value, 1 and negative 1/3, is not the final answer because it's u value. This is not x, que es my original variable. No. 1 and negative 1/3 is u value. So I need to find the x value associated with this. But this is super, super easy. This is the easy part. The complicated part, I did that. Okay? Everyone follow me? What's the idea? Okay, look. To say I want to copy only the information I need to finish that problem. Okay. I suppose you remember. No, you don't. You remember? No, you have here. Look, the chain of variable was u equal x squared. In that moment, I take a US1. Look, US1, and US equal negative 1/3. Some people have problems to connect it with. I don't know why. So you need to make a decision. So you cannot connect it, you cannot take this class. This is, I don't know, this is complicated issue. Internet connection, computer, quality of computer. This is not depending on me. See, we cannot connect it, we cannot take the class. That's it. So now, in order to find the x value, you replay here. This is x squared. No u anymore. No, it's 1. And this is x squared equal negative 1/3. Wow. So in this moment, I have 2 quadratic equations. And you solve them separately, but it's too easy. You are doing by square root method. Square root both sides, x is equal plus or minus 1. Remember, when you apply square root, double sign. And here exactly the same. Well, in this case, x equal plus or minus again. The square root implies double sign. And this is I square root 1/3. Because it's negative side. You can leave it like that, or you can a little bit rationalization. Okay, this is cosmetic part. You leave it like that, perfect for me. The rest is just cosmetic algebra to write elegant solution set. Okay, rationalization is, the student that don't remember very well rationalization, let me explain. Suppose the square root 1/3 is the square root 1 divided by square root 3, and you multiply top and bottom by square root 3, you have square root 3 over 3, no? Because radical 3 times radical 3 is 3, and this is equivalent to this, and you can write like that, plus or minus I, radical 3 over 3. Either way, guys, you leave it like that, perfect. Solution set. How many solutions in total we have in this equation? Do you remember at the beginning? It's polynomial equation, degree 4, no?
Yes.
Therefore, so we expect 4 solutions. 4 solutions, 2 real, is plus or minus 1, comma, and 2 imaginary or complex. In this case, pure imaginary, plus or minus I radical 3 over 3. Or without rationalization, you can write like that. Any question? This is quadratic inform. The student remember very well because say don't remember the name, but remember professor. This is the equation that we are using U. Because okay. What is the idea for the equation? The equation contains one expression and exactly the same expression. But this exponent is suppose A and it's a B. But this exponent que es A is twice B. And when this situation happens, suppose that this coefficient is 2, this coefficient is 3, this coefficient is 10 equal to 0. When you replace expression equal to this expression, this package equal to, you have 2UA or plus 3. Okay, no. UB, sorry. UB. Entonces, U square, because this is twice this. Plus 3, U plus 10 equals 0. And you convert this complicated equation que contain one weird expression. You see now, next example, I promise it's hard. In one elementary quadratic equation, and you solve it by quadratic. Confusing? Very, very confusing?
Yep.
Okay, I know. Let's practice. You help me, and you help me to understand. The next example is unbelievable, but true. This is the education is complicated. Maybe you don't understand very well. One example, however, when you see next and next, you get the regularly. This is a training process. Okay. Question number 1, is polynomial equation, yes or no? Is polynomial equation, yes or no? No. Very well. Why no? What is the reason? Because what is the reason? Que es no polynomial.
Negative exponent.
The exponents are not whole numbers.
Exactly. Negative exponent. No whole number. Negative exponent, no polynomial. So this idea degree something, no. Forget about it. It's invalid in that case. My next question is, So the answer was no polynomial. Okay. Next question, is quadratic in front? Yes or no?
Yes.
Yes. Why? Because this exponent que es negative 2 is twice this exponent que es negative 1. Entonces now I make a decision que for solving this equation I using U substitution. U is equal something. This is the more complicated part. What do you propose to get U? What do you propose me get U? Well, U is always the part that contains smaller exponent. Well, the actual value, no? That part here. Because this is twice, this is U2 or U squared, sorry. Okay? So when you rewrite, when you rewrite the new equation using U variable, this is 3, no problema. This is negative 14, no problema. This is U, because but this what this is, I create this definition. And this is 5, and this is U squared. Yes or no? And this new equation now is quadratic. And we solve them like a quadratic equation, but you find first U value, and after you retrieve, get x value. By the way, let me try. I don't feel comfortable with this negative exponent. So this is equivalent to say 1 over x. The negative exponent is reciprocal. Right? At least for me, it's much better like that. This is okay, but I don't like negative exponent. Everyone follow me? The analysis? Good. You say yes. Okay. Now let's go to the famous quadratic equation, quadratic formula that we're using every day in algebra. AFI, B is negative 14, and C is negative 3. The formula minus B plus or minus square root B squared minus 4AC divided by 2A. In our specific example, B is negative 14, double negative become positive. Inside the radical, we have negative 14 squared minus 4 times 5 is 8 times 6 is negative 3. Divide everything by 2 times 5. So I take my calculator. I put in my calculator negative 14 squared. I get this answer. 196. Now be careful with the sign. Double negative become positive. Positive what? Positive multiplication. 4 times 5 is 20, times 3 is 60. And you adding now is 256. And square root 256. Again, I put in my calculator and the answer is 60. Now, so far, my calculator.
I have a question here where it says, on the formula where it says negative B, positive or negative, you put 14, but isn't the 14 already negative? And
look. This is negative formula. This is negative value. When you substitution here, look, minus this minus is this minus. Parenthesis, negative 14. What happened with the double sign?
It cancels out.
Exactly. Become positive. Okay?
Okay.
So it says 16 divided by 10. 16 was the answer for the radical part. And 2 times 5 is 10. Okay. I separate 14 plus 16 divided by 10. And 14 minus 16 divided by 10. Entonces you compute that separately. This is 30 divided by 10 is 3. Remember, this is solution, but this is u value, u3. No x. I need to find x. And this is negative 2, no? Divided by 10. Okay, when you reduce in lowest term, it's negative 1/5. Okay, so we get the solution in that moment in my hand. For the u value, I need to investigate now the x value. To investigate the x value is super easy. Almost we finish. Because the only thing you should do is substitution. This value 3 and negative 1/5 here. Let's do it. Okay. I would like so much. Organization is important in mathematics. I separate the paper in 2 pieces. Here, I copy. U equal 3. U equal negative 1/5. Okay, what's the solution? Okay, we get that. However, for one corner of the paper que I erase, unfortunately, I have que U is equal 1/x. Reciprocal, ¿no? Entonces 1/x is equal 3. And 1/x is equal negative 1/5. And now in this equation, the Caesar equation, you solve for x. You have some idea how we solve for x? Well, one easy way, there are many ways. One way is flip it, that part. You flip it that, you get x. And so you flip it that, you get 1/3. Yes or no? It's possible or impossible to do that? Yes. Another way to see that is 1/x equals 3. And you consider it like a proportion, and 3 is a whole number. And so you consider it gets 3/1, and you apply cross multiplication like that. Pam, pam. So x times 3 is 3x. Cross multiplication like that. And 1 times 1 is 1. Finally, divided by 3, you get 1. Okay? Here, in order to do fast, flip it, x equals -5. So what is the solution set for our equation? One, two solutions. Normally, the quadratic in front contains only two solutions because the idea for the degree has no sense. Degree is only for the polynomial equation. This equation is crazy, quadratic in front, have no degree, have no sense to talk about the degree, and we have only two solutions. Well, not only, sometimes, the majority of the case, we have two solutions, -5 and 1/3 as the final answer. A little bit more clear or confusing? This is important. In the test, you can see 1, 2, 3 equations like that. Quadratic equation. Quadratic in front. Quadratic in front. No quadratic equation. Quadratic in front. Question, please. Everyone get the idea? No? Are you lost?
No.
Totally lost? Go ahead, go ahead. I repeat several times the idea in order to you understand. You are my business. Okay, I would like you understand very well everything. A ver, let me see. In the chat. Everything okay, guys? Try to answer in the chat or activate the microphone. Everything okay? You understand very well the quadratic form equation?
Yes.
No?
I'm
No?
understanding little by little.
No.
No what? Come on. I want a smart question. The smart question is you specification, the part that you don't understand. The stupid question is I don't understand anything because you don't give me any clue to explain to you. Okay, so you will be able to specification what is your point. I can help. Otherwise, no. Do you see the board? Do you see the board? Okay.
Yes.
Okay. Number one question. Number one. Is a polynomial equation poly? Is poly or no?
No.
No, no poly. So si es no poly, have no sense to talk about degree. However, this is quadratic in front or no? No. Quadratic in front. Yes, Olga.
Yes.
Rosalinda dice no. Rosalinda, no. Do you understand? Okay. Remember the clue for identification que es quadratic in front is you have two exponents. This exponent 2/3. This exponent 1/3. Es obvio que 2/3 is twice 1/3. Therefore, this is the only thing that you need to know to identification is quadratic in front. Okay? To say yes. Okay. Yes, quadratic in front. The quadratic in front means que es the equation que you solving using the chain of variable que es u. This is my u. Entonces my u is, who helped me to say? Exactly. X to the 1/3. You say little by little you learn? Okay, now ready to rewrite the equation again, but using now a new auxiliary variable. -7u, because by definition, this guy was u, and this is twice, so this is u squared. Wow, easy. And you get super elementary quadratic equation. Super elementary quadratic equation. Let me rewrite it. Go ahead.
I thought we take the greatest. I might make myself look silly right here, but I thought we took the bigger of the exponents to substitute. I thought 2/3 was more than 1/3.
Okay, I don't understand anything. Okay, what is your point? What is your question?
I thought that u would have to be 2/3 instead of 1/3 because we take the bigger.
Okay. The glue is you take always u like the part in which the variable I can explain or no? Okay. Okay, it's important communication. I don't understand anything. Okay, you activate the microphone or typing in your chat your question, a specific question. I believe I understand. You say the U for U is 2/3, not 1/3. Yes or no?
Yes, because the first
Uh-huh.
that you
Uh-huh.
gave us.
The answer is no. The answer is no. Why no? Because you take always the smaller exponent. Why? Because you consider que es smaller as u, the other que es twice is u squared. And this is the quadratic equation. Now this in blue color is quadratic equation.
Okay, I wrote it down. Sorry.
Okay, perfect. Do you understand, mister?
Yes, sir.
Eso. Bueno. Okay, now we focus in the solution for the quadratic equation. By the way, this is super elementary. We need to apply quadratic formula or we can do by factorization. What do you think? Let me copy. The equation that we have so far is u squared minus 7 plus 10 equal to 0. It's possible to do it by factorization, guys. Factorization trinomial. Or no? Honestly, you remember factorization or you don't remember factorization? Yes, it's possible. What is the combination in that case? Two numbers can multiply each other.
5 and 2.
Eso. 5 and 2. Very well. What sign?
Positive and negative.
Both negative. Why? Because when this sign, both negative. Because when this sign is positive, look, multiplication, negative 5 and negative 2 is positive 10. We need negative both. The same. When this sign is positive, it's the same. My microphone off. I am one teacher here, only one. It's me, right? You ask me a question, yeah, I answer your question. It's not the classroom that some students want to participate. No. One teacher, only one. Now, you adding, for example, negative 5 plus negative 2, we get negative 7, like that. Negative 7 and positive 10. Look at that. Okay, guys. This is the moment to make a decision. You don't like factorization, I don't care. We can do that using, again, one more time, quadratic formula. But this is a piece of cake. It's elementary. Okay. I respect any opinion. Suppose the student get, I don't remember factorization because when I take MIT 1033, I forgot everything. Okay, no problem. However, you remember quadratic formula, A, B, C, right? A is 1, look at that. B is negative 7, and C is 10. And you apply the quadratic formula, minus B plus or minus square root B squared minus 4AC divided by 2A. Entonces 7. You understand que es 7, no? Because double negative become positive. I don't need to repeat again, no? Plus or minus square root negative 7 squared minus 4 times 1 times 10 is C. Everything divided by 2 times 1. A is 1. Negative 7 squared is 49. Minus 40, no? Because 4 times 1 is 4, times 10 is 40. 49 minus 40 is 9. And the square root of 9 is 3. So far we have 7 plus or minus 3 divided by 2. Let me copy here. And you see we get exactly the same answer. In factorization, remember the answer was 5 and 2, no? Okay. Entonces, okay, es 7 plus 3 over 2. Look, I break it down, this plus and minus, and plus and minus separately. 7 plus 3 is 10. 10 divided by 2 is 5. And 7 minus 3 is 4. And 4 divided by 2 is 2. It's exactly the same the combination. 5 and 2. 5 times 2 is 10. 5 plus 2 is 7.
There's a sushi sake in Hialeah.
What do you say? Hialeah. Ajá. Entonces, bueno, I feel it. No, I don't. This is U value, remember. U5, U2. I need to find the X value. This is a complicated part. Because remember, the original equation contained fraction exponent, no? And remember the definition for the U was 1/3. 1/3. 1/3. Okay, so you let me know when you finish to copy the solution for the quadratic equation. Okay, let me try. While you copy, let me summarize a little bit the idea. We have equation. This equation is no polynomial, no, but it's quadratic in front. The reason is that we have two exponents and the one big exponent is twice the second. So I take advantage of this fact. I create U substitution. You tell you always like the smaller exponent and the second gets twice U squared. So actually we convert a complicated equation in one quadratic equation. It's a fantastic. And you solve this quadratic equation by factorization, by quadratic formula, whatever you want, and you get the U value. I finish, no. The last part now is, you have the U value, case 5 and 2. Okay, so I'm using this U value. I split the paper in two parts. U equal 2. U equal 5. Well, who is U? What is the relationship? What is the formula? Give me a relationship between U and X. This is a formula. Is X 1/3. Very well. Very well. Okay, X 1/3. Entonces in this moment I am a little bit confused. What kind of equation it is and what kind of equation it is? Well, let me rewrite this fraction exponent like a radical notation. This is a cubic root X. Do you see that or no? Do you remember how? Okay, cubic, two cubic equation. Very well. It's a radical equation. Meaning no. Olga is a no. Olga, what mean no? You don't remember conversion fraction exponent to radical?
No, I don't remember.
You remember? No, remember?
I don't remember.
Okay, I refresh your memory. Now, look. Guy, in the morning, I teaching intermediate algebra. Okay? This is called algebra. I suppose you know that. Okay, don't worry, be happy. Look, suppose you have X raised to the 4/5. How you convert to the radical notation? It's a fraction exponent conversion, fraction exponent to radical notation. The variable is X. The number in the denominator, 5, represent the index of the radical. And the number in the numerator represent the power. You can write like that, or you can write like that. It is the same. It's equivalent. In our specific case, is 1/3. The index is 3, and the exponent is 1, is invisible. 3, and the exponent is 1, is invisible. Now you see? Olga?
Yeah.
Okay. Okay, now finally, so we have in that moment two radical equations. This is what should I do for solving any radical equation I explained in the last class? What should I do for solving any radical equation? que I explained the last class.
Square.
Ajá. In this case, no es square, it's cubic. Cubic both sides. Yes or no? Cubic both sides. Because this cubic allow us eliminate the cubic root. This is just x, and this is 2 to the third power, que es 8. And this is x, and 5 to the third power, que es 5 times 5 times 5 is 125. And the solution set for our equation is two solutions, que es 8 and 125. Any question? Any question? Wait, I forgot something. Entonces I explained in the last class that when you solve the radical equation, you need to check it. Yes or no? Always. Mandatory, right? Do you remember that? No? Why no? Michael Aguirre, he said no. What mean no? Yes. All right, Michael say yes. What mean yes? Okay. My question was, in the radical equation, you need to check it or no? Michael Aguirre say yes. Okay. Es no. Why no? Because I explained in the last class that when the index of the radical is odd number, never you have extraneous solution. So you don't need to check. Always when you have even number, suppose que the index is 2, 4, 6, entonces you have to check. Okay? Okay?
So basically, if it's a number, you check your answer. If it's an odd number, you don't check it.
Exactly.
Perfect.
Okay. Let me summarize. Let me compact the idea. The idea is you have a radical equation, but the index of the radical is odd number, like a 3, like a 5, like a 7. You don't need to check it. You cube both sides, no problema. Easy. When the index is 2, 4, 6, even number, you are square or 4 power, whatever you want, but this answer contains mistake. Not always, I don't know si it's always, I need to mandatory checking, and si es true statement, okay, it's solution, pero si es not true statement, it's not solution. So when the index is even number, like the example, the last example, I don't know if we have time to finish because it's too long. Look at that. Okay, copy that. Okay, this is polynomial, poly, yes or no? No. Jovino say no. Es quadratic in front, Jovino?
Quadratic formula.
Yeah. Rosalinda dice no. No what? No poly, no? And quadratic in form. Yes or no? Junior. Jovino say yes. Okay, good. Entonces we solving using U substitution, no? Entonces, what is the expression? Yes. Sergio López dice yes. Entonces, what is the expression que you define U? 1/2 or 1/4? 1/2 or 1/4? Okay, some people say que 1/2. Some people say que 1/4. Nobody? 1/4. Okay. What is the smaller? 1/2 or 1/4? What is the smaller?
1/4.
1/4. Entonces 1/4. No 1/2. Wrong. 1/2. 1/4. Sorry. 1/4. A 4 here. You take the smaller exponent, is 1/4. So you put 0, -7, -13 u, and this is 2u squared. Yes or no? Because when you square both sides here, you multiplication by 2 is x to the 1/2, because 2 divided by 4 is 1/2. And this equation now is quadratic equation. Everyone understand very well the idea or no? Confusing? You have to practice.
Not confusing.
No confusing. Okay. Very well. No confusing. Okay, entonces we apply one more time quadratic formula. You see que quadratic formula we're using every day. Oi, noise. I hear a child, a children. -7. Entonces the formula is minus b plus or minus the square root b square. I suppose que nobody asked me any more about this formula, no? Because we are using a lot of time last class and this class. Entonces 13 positive, double minus, plus or minus square root -13 square minus 4 times 2 times -7 divided by 2 times 2. ¿Qué sé? -13 square, I put in my calculator, is 169. Positive. And double minus become positive. 4 times 2 is 8, times 7 is 56. And together is 225. And the square root 225, one more time, I put in my calculator is 15. So far we have 13 plus or minus 15 divided by 4. Because 2 times 2 is 4. So I separate 13 plus 15 over 4 and 13 minus 15 over 4. 13 and 15 is 28 divided by 4 is 7. Good. And this is -2 over 4 is -1/2. Okay, good. So this is a solution of the quadratic equation after the transformation, after the change of variables. This is a u value, u7 and u -1/2. But I need to find x value. Is the original variable. Okay? Do you copy that? Let me try to do the last part. The last part is split the paper into parts and solve the equation. May I erase or no? At least, yes, okay. At least that part. Because I focus in the last part. The last part is you split the paper into parts. Yeah, I know. Okay, u is 7 and u is -1/2. But who is u? Remember, u was, I erased, unfortunately, is x to the 1/4, no? This is definition for the u. That allows us to simplification the equation, no? This is x to the 1/4 equals 7, and this is x to the 1/4 equal -1/2. And this is equivalency. I don't feel comfortable with the fraction exponent. Actually, I don't like. You copy like a radical
Professor,
please.
I thought it was x over 1/2, not 1/4.
No. Sorry. U was x to the 1/4. I discussing in detail that part because what is smaller between 1/4 and 1/2? What is smaller?
1/2.
No, 1/4. Look what happened, guy. This is the bread. You divide it by 2 is 1/2, 1/2. This is the same bread divided by 4. It's like that. It's a 1/4. You eat that part, I eat that part. Who eat more? Hello? Okay? Okay, get clear? So the small number is 1/4. That is the reason I take 1/4 like a u. Miss, do you understand or you don't understand?
I understand now.
Okay. Now, I explain the thing is I don't like this fraction exponent. I feel not comfortable. No, QB, no. Olga, no. This is 4 root, Olga, of 7. And this is 4 root of x is equal -1/2. So you, in order to isolate the x, you raise to the 4th power, no QB. Raise to the 4th power. Because the index is 4, not 3. And in another example, yes. But in this example, it's 4. And this is x equal. Here I put in my calculator 7 raised to the power 4 is 7 times 7 times 7 times 7, 4 times, que es 2,401. Okay? And here, exactly the same. You raise to the 4 power 1/2 times 1/2 times 1/2 is obvious que 1/16. And that's it. I finish. I finish. What do you think? You need to check it or no?
Yes.
Yeah. Well, unfortunately, we have no time to check it, but this is just elementary arithmetic. You plug in this number into the original equation, and you verification that this is true statement. This solution works. But when you plug in this and the original statement, this is completely false. Now, solution set for this quadratic form equation is only this solution. If you want, we start next class doing that part because it's too easy. It's just arithmetic. You try you for homework, doing the checking part. You plug it in, you say calculate, of course. Okay, guys. What do you think about this algebra? It's hard.
It's fun.
I know. It's what? It's hard or it's easy or it's funny?
Fun.
Hard. I know. Okay, unfortunately, okay, let me explain something. This class, traditionally, start 20, 30, 32 and 32, 33, 35, and ending less than 20. Okay, it's hard. And you need to be dedicated student. No? Okay, and I am open to any question, anytime. When you are doing, but you have to study. I cannot study for you. You have to study. Okay, guys, let's see. So this weekend, I suppose everyone working in Alex. Alex doing the homework, and the advanced students start doing the pre-test. Because remember, we spend next week 15. We continue that part. I suppose we finish. And start review. And 17, we finish the review. I send the test on paper, and everything is due next week, Tuesday. It is September 20, 20 what? 20 what? 20, 24, no? Or 22nd, no? 22nd. 22nd, no? Let me see in the syllable. The syllable said the truth. 15 and 17 review. 22nd. 22nd, we start new chapter. Yeah, I forgot test number 1. Okay? So we have the entire weekend to do the test on paper. Yeah, I suppose we start the test online right now, as soon as possible. When you feel strong, remember, you can take 2 times the test online. And pre-test, infinity time. Practice. When you feel comfortable. Okay? Okay? No problema. Everyone understand? I have a question about the Alex. Stay. You can leave, guys. Stay only the student can have a question.
Professor. Thank you.
Okay, take care. Some people say they have a question about.
Yes. Hi, Professor. It's Olga.
Olga.
How are you?
I want to see your face, Olga.
Okay.
Si es possible.
Hello.
Hello, how you doing?
Hi. Okay.
What can I do for you? What can I do for you?
I plugged in the code for the 2-week access, like you provided me in the email, and you had mentioned in the first class that we didn't have to do the initial knowledge check, but it doesn't load the assignments for me until I guess I complete that section. So it's not loading anything under assignments.
No. Initial knowledge you skip. How you skip? Maybe you cannot skip at the beginning, but you click next. I don't care.
Okay.
I don't care. See, you get 0 point here. I don't care. The good for me is homework 1, homework 2. How many homework? Homework 3, no? 2 homework, no? 2 homework. Let me see in Alex. 2 homework, right? Let me see. I look at the assignment now. The assignment is MAC1105. Assignment. Ajá. 2 homework, 3 tests and tests. That's it. It's the only thing que I create for you. Y el the second test is similar. 2 homework, 3 tests and tests. No model, no initial knowledge. No, I don't care. Okay. Initial knowledge is like a tour que Alex create to be familiar. You are familiar with the Alex. Okay.
How I heard you mention that we have to do like the test on paper, or they're in Alex. Like after we do the 2 practice.
We have 2 tests.
Okay, on Alex.
Okay, listen. No, in Alex no. We have 1 test in Alex and 1 test on paper that I will send to you September 17th.
Okay.
You receive by email. Okay, you have the entire weekend for doing that. You took a picture and the test on paper. You send me back for the email. Okay. Listen, the formula que I use to compute the overall grade is test 1 on paper plus 1 online plus test 2 on paper plus 2 online plus 4 divided by 8, because in total we have 8 tests. 4 chapter, 2 tests, 1 on paper and 1 online. Do you understand?
Yes.
Okay, this is my rule. Okay, so you accept my rule, you stay in the course, no? So you don't accept, you don't accept.